Hello everyone! Today, we're going to solve an integral problem from the 2021 Oxford Admission Test. You can see the question on the screen. It says the following. Which of the following option represents the area enclosed between the curves y equals e to the power of x and y equals 1 minus e to the power of x and the y-axis? Now, universities like Oxford usually don't include graphs in their questions. It's similar in math Olympiads. If a graph is needed, it's up to you to draw it. So let's sketch the graph ourselves and see how it looks. Maybe we'll find a good path to the solution that way. Let's move the question to the top left corner and draw on the right side. We'll begin by drawing a coordinate plane. Now, how can we graph a function we're not familiar with? Actually, if you plot just 3 to 5 points that lie on the curve, it becomes pretty easy to understand its shape. Before we start, let's quickly recall what e is, the Euler's number. It's an irrational number, just like pi. Its approximate value is 2.718, and it keeps going forever after the decimal point. A very interesting number. I'll explain it in more detail in a future video, so stay tuned and don't miss out. Now, for the graph of y equals e to the power of x, let's mark a few points. When x is 0, e to the power of 0 is 1, so the point is 0,1. That is here. When x is 1, we get about 2.718, that's here. And when x is negative 1, we get approximately 0.36, so the point is minus 1, 0.36, that's here. You don't need to calculate these values exactly. Just to make it easier, you could even use e as 3, and the general shape would still be very similar. So as you can see, as x increases, the function grows rapidly, and as x decreases, it gets closer and closer to 0. That means the graph of e to the power of x looks something like this. All right, now let's draw the graph of the second function, y equals 1 minus e to the power of x. Let's clear the screen a bit. We'll do the same steps, just a little faster this time. When x is negative 2, we get around 0.87, which is here. When x is 0, the result is 0, which is here. And when x is 1, we get about negative 1.718. So we plot those 3 points and connect them smoothly. That gives us the curve for 1 minus e to the power of x. All right, we've drawn both curves. Now let's clean up the screen, remove the extra points, we only needed the graphs. Let's keep the screen nice and clear. Now the question asks for the area between these two curves and the y-axis. Before I mark anything, can you try to guess where that is? Yes, I think you've got it. It's this yellow region right here. Now before we write the integral, we need to find the limits. That means we need to find where the two curves intersect. So we set e to the power of x equal to 1. If we move one of them to the other side, we get 2 times e to the power of x equals 1, which means e to the power of x equals 1/2. To find x, we take the natural log of both sides. That gives us x equals the natural log of 1/2. So this point here is natural log of 1/2. All right, now we know our boundaries. The integral goes from natural log of 1/2 to 0, and the integrand is e to the power of x minus 1 minus e to the power of x. Now we integrate that. But here's something interesting. The derivative and the integral of e to the power of x is e to the power of x. Isn't that amazing? Can you think of any other function like that? We'll dive deeper into this idea in a future video. So back to our integral. The antiderivative of 2e to the x minus 1 is simply 2e to the x minus x. Let's plug in the limits. When we plug in x equals 0, we get 2 minus 0. When we plug in x equals natural log of 1/2, we get 1 minus natural log of 1/2, which simplifies to 1 plus natural log of 1/2. That's not one of the choices in the answer options. So what do? Let's remember that natural log of 1/2 is the same as natural log of 2 to the power of negative 1, which becomes negative natural log of 2. So this expression becomes 1 minus natural log of 2. The correct answer is option B. I'm sure many of you solved this question on your own. Oxford does ask tough questions sometimes. Not all of them are this easy, but we'll go over the harder ones together in future videos. I hope everything made sense. Let's chat in the comments, and I'll see you in the next lesson.